So in TCP, to help you with an example, we can take an example of the same three-way handshake, how it can be exploited. So we bring up our Mr. Hacker and also our server machine. So of course, the hacker would go ahead and first initiate a lot of sync packets. That's important, you see here, a lot of sync packets. So up until now, everything is fine. Our server would also acknowledge the sync packets and also send another sync that yes, I'm okay to initiate the connection. But this is how it all begins. So every sync packet that the hacker or the malicious bad actor sends, it consumes some amount of memory and time in your server. And server waits an X amount of time or X period of time before it calling it a connection termination. Uh, so this is exactly what a hacker tries to do. It will send a sync. It keeps sending sync packets and keep occupying memory and the CPU or the utilization of bandwidth, so that the server gets so busy in maintaining the connection that legitimate users or clients who would want to reach out to the server are not able to reach out to the server. Hence, there's something that's called denial of service that happens. Let's understand a UDP DOS attack or a DDoS attack as well. So we got our Mr. Hacker or the bad actor once again trying to relay some UDP or spoof packets using a bot. In this case, the attacker is using a bot to send some spoofed UDP packets. But what's happening is here, it's not using its own real IP, it's using somebody else's IP address. It'll send the crafted, especially crafted packets where it will have the source IP of somebody else's and sent to the target device. Now, the target device will say, hey, I just received a ICMP packet, I should just reply to it, right? It will get so busy replying to the ICMP packets, and it will every time receive an error message that the source machine didn't even try to initiate the packet. This in turn will consume the target device's resources and will and the resources would quickly be exhausted when a large flood of UDP packets are being spoofed and sent to it, resulting in another denial of service to the legitimate or normal traffic. Now that we studied TCP and UDP and how they can be exploited or abused, let's try to understand how can we mitigate the TCP and UDP attacks for with just the example we just went through. Remember TCP, where we had sent the TCP half-open packet and it consumes the memory of the device. So that is something that you can simply do. That is reusing the memory of the sync backlog and by deleting the half-open connection packet. That is, you set a expiry time to the TCP sync packets, and after a certain period of time, it gets deleted. The memory is free, so that it can accept more connections. You can also enable the firewall to detect and filter sync packets, especially if it's getting bombarded with sync packets. It is also possible to configure your firewall to prevent or limit the impact of this kind of DDoS attack. Most modern firewalls would come built in, out of the box with this capability. And to mitigate the UDP attack, you can limit the response rate of ICMP packets, in part to disrupt the DDoS attacks that acquire ICMP responses. So that was about this video to explain the differences between TCP, UDP, and how the protocols can be abused to launch cyber attacks. I hope you all the best on your interviews. All right, bye now.